In this tutorial, you will learn how to use NetGestalt's filters and data transformation tools. First, let's look at an example of value-based filtering. Value-based filters are available only for single continuous tracks. In this example, in the top track we have a gene expression heat map comparing the normal versus adenoma samples. Below, we have a single continuous track showing the log ratio in the difference in gene expression between normal and adenoma samples, and finally, a single binary track showing the pre-computed significantly differentially expressed genes. Let's apply a filter to the single continuous track to show only those genes with the log ratio difference in expression that is greater than 1 or less than -1. Select the value-based filtering option under the track menu. Select the filter type option, input your filter values, input a track title for your new track, and click Add Track. As you can see, a new single binary track of filtered genes has been created that looks very similar to the single binary track of significantly differentially expressed genes already loaded. But when we zoom in, you'll see that the newly created single binary track still contains heat mapping colors reflecting the continuous values in the pre-filtered track. Next, let's look at presence-based filtering options available for single binary tracks. With presence-based filtering, you can visualize the data for all of your loaded tracks, but only for the genes present in the selected single binary track and visible at your zoom level. For example, let's apply the presence-based filtering to this single binary track while zoomed in. As you can see, all of the track data is presented, but only for the genes that were visible and were in the single binary track. Next, let's look at the data transformation tools available for single continuous and composite continuous tracks. In this example, let's assume we are interested in finding KEGG pathways found to be enriched with differentially expressed genes between normal and adenoma tissue. We can first conduct the gene set enrichment analysis on KEGG pathways as discussed in tutorial 5. Next, let's select one of these enriched pathways. How about the pyrimidine metabolism pathway? Let's create a track at the intersection between our track of interest and the pyrimidine metabolism pathway. Since no genes in that intersection are visible at the current zoom level, let's zoom out, find a region of interest, and zoom in to get a closer look. Notice how a number of the genes in the pyrimidine metabolism pathway are differentially expressed, but at a log ratio much less than 1. If we wanted to visually inspect the set of moderately differentially expressed genes more easily, we can use the data transformation tools. For composite continuous tracks, the data transformation option lets you subtract the gene-wise median or mean to improve data visualization. You can also set new floor and ceiling values to focus the heat map on ranges of interest. The dark red and dark blue heat mapping options are set to the minimum or maximum values of the track by default and can therefore be skewed by outlying data. You can optionally select a different heat map color scheme. Select the type of gene-wise standardization method, select a heat map color scheme, input a floor and ceiling value, and finally click Update. In this case, we're going to shrink the floor and ceiling range to focus on the less differentially expressed genes. Similarly, for a single continuous track, let's also shrink the floor and ceiling ranges. Notice how the outliers are now represented by red or blue bars. As we can see, the data transformation options can be useful for adjusting the range of values used for NetGestalt's visualization tools and dealing with data outliers. This concludes tutorial 6.